Good afternoon, children. Okay. Now we are going to discuss about the chemical bond. In that chemical bond, some topics are we are going to discuss now. Okay. Yeah. The first one, now we are going to discuss about the hydrogen bond. Hydrogen bond. Hydrogen bond. So see here, sir, what is a hydrogen bond? Okay, hydrogen bond is a weak electrostatic bond. Hydrogen bond is a weak electrostatic bond. The bond formed partially positive charge hydrogen and partially positive charge hydrogen with highly electronegative atoms. Highly electronegative atoms like fluorine, oxygen, nitrogen with the same molecule or another molecule. With the same molecule or another molecule, hydrogen bond is formed. Okay, right. Simply we can say that hydrogen bond means the hydrogen bond formed between hydrogen and highest electronegative element like phone element. I'm calling phone element, you see. Phone element. In fluorine, it's not a phone, it's a phone element. Fluorine, oxygen and nitrogen. These elements are form the hydrogen bond with the hydrogen within the same molecule or different molecule. Okay, so then a hydrogen bond is formed. This hydrogen bond, to break the hydrogen bond, we require 40 kilojoule per mole. What is it? 40 kilojoule per mole energy is required to break. And a hydrogen bond is indicated with the dotted line. So this type of dotted line is indicated hydrogen bond. Okay. Again, you see this hydrogen bond is divided into the two types. Hydrogen bond divided into the two types. What are those? Now let us see. One is intermolecular hydrogen bond. Intermolecular hydrogen bond. One is intermolecular hydrogen bond. Sir, what is intermolecular hydrogen bond? The hydrogen bond formed in polar molecule. The hydrogen bond formed in polar molecule in between two molecules. In between two molecules of hydrogen and highest electronegative atom of fluorine or oxygen or nitrogen. Okay, sir, you give examples, sir, we are able to understand. Now you take the example. The example is that HF, another one H2O, another one ammonia, another one para-nitrophenol, para-nitrophenol. So these are the best example for intermolecular hydrogen bond. Best example. Okay, now see hydrogen bond inter. One point to remember: inter. Inter means hydrogen bond formed in between two molecules. In between two molecules. Okay, so this is one molecule, this is one molecule. In between two molecules, hydrogen bond is formed. That is inter. Here example, the hydrogen bond formed between HF molecule and HF molecule. See, in between two molecules, hydrogen bond formed. Hydrogen bond formed. Okay, electropositive atom hydrogen and highest electronegative atom with fluorine. So this is hydrogen bond. If the hydrogen bond is formed in between two molecules, that is intermolecular hydrogen bond. Okay, so here also water molecule also hydrogen bond it will be formed, and ammonia also hydrogen bond it will be formed. NH3H, NH2H, hydrogen bond with NH2H. So it will be continued like this. So here a hydrogen bond with hydrogen and highest electronegative atom with nitrogen. Here water. Now see here. In water, H2O, hydrogen bond, highest electropositive of hydrogen atom and highest electronegative of oxygen atom. Hydrogen bond is formed. Okay, even para-nitrophenol also hydrogen bond it will be formed. I'll draw the structure, you see. See, this is one orthonitrophenol or para-nitrophenol. Para-nitrophenol. This is also, what is this? Para-nitrophenol. So, two para-nitrophenol, two molecules have taken. One molecule of oxygen, another molecule of hydrogen is participated in the hydrogen bond. So here the hydrogen bond formed in between two molecules. So that's why this is comes under intermolecular hydrogen bond. Intermolecular hydrogen bond. Okay, right. Next, we are going to discuss about the intramolecular hydrogen bond. Intramolecular hydrogen bond. Intra, it means that the hydrogen bond formed within the molecule. The hydrogen bond formed within the molecule. Molecule one only. See, example. Example, now I am going to take orthonitrophenol. See, this is orthonitrophenol. To understand, I want to write like this. OH-N-1-1-O. This is ortho position. On benzene OH group is present, that is a phenol. Orthonitrophenol. Single molecule only. In a single molecule, hydrogen is formation of hydrogen bond with oxygen. Hydrogen bond formed in one molecule only, within the molecule only. So, within the molecule, hydrogen bond is formed. That is intramolecular hydrogen bond. That is an intramolecular hydrogen bond. Okay, right. So, another one example also we are able to take. See, orthonitrobenzoic acid. Orthonitrobenzoic acid also. Orthonitrobenzoic acid. Clear? Orthonitrophenol. It's a single molecule only. So within the molecule, hydrogen bond is formed. That is the intramolecular hydrogen bond. Okay, here also see orthonitrophenol. Within the molecular hydrogen bond is formed. That is also comes under intramolecular hydrogen bond. So now here one question is arises. Now here one question is arises. The question is so very important for competitive level also. Sir, one doubt. To break the hydrogen bond, 40 kilojoule per mole energy is required. Okay. Sir, you are telling that hydrogen bond is divided into the two types. One is intramolecular hydrogen bond. Another one, intermolecular hydrogen bond. This is inter, this is intra. Okay. Sir, these two bonds, same energy is required or different energy? This point to remember for the competitive. The point is that intramolecular hydrogen bond, it is a weak bond. Why? Because the bond formed within the molecule. See, I'm a molecule. Within the molecule, hydrogen bond is formed. This is weak. Is easily to break the bond. If I form the bond with others, okay, that bond is strong. Mean in between two molecules, hydrogen bond is intermolecular hydrogen bond. This is a strong bond. Within the molecule, hydrogen bond is formed. That is the weak bond. So that point to remember. This is the weak bond. This is the strong bond. This is the weak bond. This is the strong bond. Okay. Sir, one doubt. This hydrogen bond affects the many physical properties. Hydrogen bond affects the many physical properties. Due to hydrogen bond, number of physical properties are changes. Sir, what are those? See, those points you remember. First one, see, due to hydrogen bond, boiling point will be changed. You remember this point. Boiling point. Okay. Now see, CH3O, CH3, CH2OH. Here I have taken two molecules. This is ether. This is alcohol, ethanol. This is alcohol. This is ether. Two compounds molecular formula same. What is that? C2H6O. This is also C2H6O. Two molecules, molecular formula is same, but this is having highest boiling point. This is lowest boiling point. This is highest boiling point. Boiling point of alcohol is highest. Boiling point of ether is lowest. Why, sir? Why? Why means alcohol, oxygen adjacent hydrogen is there. Here oxygen not having the hydrogen. Then you understand how they affect the hydrogen bond in the molecules, changing the boiling points. See, both are having the same molecular formula, but what is going to change? It's changing the boiling point. Okay, right. See, now we are going to discuss about the another one molecule. See, ammonia as well as HCl. Now see here, ammonia, nitrogen having the electron negativity is equal to 3 only. Chlorine also electron negativity N is 3 only. Here electron negativity 3 only. Both are having the electron negativity 3. But you remember Ammonia molecule having highest boiling point. HCl has lowest boiling point. Why, sir? Why? Because already starting I told you. Four elements only formation of hydrogen bond. Fluorine, oxygen and nitrogen. Only four elements only formation of the hydrogen bond. Mean chlorine does not formation of the hydrogen bond. Nitrogen only forms a hydrogen bond. Which is nitrogen only forms hydrogen bond. That's why. Now see here. That's why ammonia has the highest boiling point. Then HCl. And one more important point, the difference is that this is orthonitrophenol. This is para-nitrophenol. Already I told you, orthonitrophenol, intramolecular hydrogen bond. This is intermolecular hydrogen bond. It will be formed. Okay, both are forming a hydrogen bond. But what I told you, intramolecular hydrogen bond is a weak bond. This is the strong bond. That's why here this compound boiling point is low boiling point. It is having low boiling point. It is having high boiling point. High boiling point. See, why? Because intermolecular hydrogen bond, strong bond. The strong bond formed, para-nitrophenol. So that's a high boiling point. Okay, low boiling point. Boiling point low. Volatility high. Volatility high. Sir, what is volatility? Volatility means evaporation. It will be evaporate fast. You remember, boiling point always inversely proportional to volatility. Volatile. Evaporates. Okay, so volatility high, low volatility. Okay, so this hydrogen bond affect the in between two molecules by the boiling point and volatile nature also affects. Okay, and the last one point to remember here. Last one point to remember. One question they will ask compulsory. H2S is a gas. H2O is a liquid. Why, sir? Why? H2SO gas means sulfur having two hydrogen, oxygen having two hydrogen. Oxygen and sulfur are both are belongs to same group, sixth group element only or 16th group elements only. But why this is liquid, sir? Why this is gas, sir? Then you understand how the hydrogen bond is changing the phase also, phase of the molecule. Liquid phase, gas phase, also it is changing. Okay, so H2S is a gas. Okay, H2S is a gas. Why? Because why? Because hydrogen sulfur does not formation of the hydrogen bond. No hydrogen bond. No hydrogen bond. But oxygen is a four element. Oxygen is a four element. It will be formation of hydrogen bond. So due to formation of hydrogen bond, H2O is a liquid. H2S is a gas. Phase also affects on the basis of hydrogen bond. Okay, and okay, so these are the properties of hydrogen bond. Sir, one doubt finally. You remember, highest strength of the hydrogen bond is depend upon the electronegativity of the element. For example, you see one question, HF, here H2O and NH3. If you compare like this, this is also formation of hydrogen bond. This is also formation of hydrogen bond. Mean water molecule also formation of hydrogen bond. HF also formation of hydrogen bond, and ammonia also formation of hydrogen bond. So in these three molecules, electronegativity is highest for fluorine. So then bond strength of the hydrogen bond is highest for HF. Why? Because fluorine is highest electronegative element. Okay now? Right. So this is the information about the hydrogen bond. Okay. Now next one, we are going to discuss about the very important topic that is coordination covalent bond. What is it? Coordination covalent bond. Coordination covalent bond. Okay. Now see, in the coordination covalent bond, it is a special type of bond. Special. Okay. This coordination bond is proposed by Sidgwick. Who is a scientist? His name is that Sidgwick. Proposed by the scientist is Sidgwick. Okay. Sir, what is the coordination bond? So, in the molecule sharing of the electrons from one molecule to another molecule after formation of the covalent bond, electron pair contribution takes place. What happens? Electron pair contribution takes place. Okay. So to understand simple way, I want to take the one example, then you understand here. The best example for coordination covalent bond, that is the ammonia and BF3 molecule. Ammonia and BF3 molecule. Okay. Here I want to say that the important point, ammonia having the one lone pair of extra, BF3 having one vacant orbital. How ammonia having the lone pair of electron? Means to understand having lone pair of electron or having vacant orbital, you should understand octet rule. Octet rule. On the basis of octet rule, it is having lone pair of electron and this is having the vacant orbital. Okay. If you are doubt about the octet rule, I'll explain next class. Okay. Simple. Octet rule means an achievement of 8 electron in valency shell is said to be octet rule. An achievement of 8 electron in valency shell. Now see nitrogen group number 5. Okay. See, I know here 3 hydrogens are joined. Nitrogen group number is 5. 3 hydrogens are joined here. See, nitrogen atomic number 7. Okay. Nitrogen group number 5. Nitrogen group number should learn compulsory. In the total periodic table, group number you have to learn. First group, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Second group, beryllium, magnesium, calcium, strontium, barium, radium. Third group, boron, aluminum, gallium, indium, thallium. Fourth group, carbon, silicon, germanium, tin, lead. Fifth group, nitrogen, phosphorus, arsenic, antimony, bismuth. Sixth group, oxygen, sulfur, selenium, tellurium, polonium. Seventh group, fluorine, chlorine, bromine, iodine, acetylene. Eighth group elements, helium, neon, argon, krypton, xenon, radon. So, like this, if you know the group numbers, okay, so nitrogen comes under fifth group. Nitrogen, phosphorus, arsenic, antimony, bismuth. This is the fifth group. Now see, fifth group I have taken 5 electrons and 3 hydrogens are participated in bonding and 1 extra pair of electrons is there. That extra pair of electrons I have written here. Okay, now see here. Boron here what happens, boron group number third group. Boron group number third. But you see, 3 fluorines are formed bond. Okay, 3 plus 3, total 6. Group number 3, 3 fluorines are joined. 3 plus 3 is equal to 6. Means it does not reaches the octet rule. This is reaches the octet rule, but it does not reaches the octet rule. That's why it is having the one vacant orbital. Okay, so here what happened, the excess of lone pair of electron of one molecule contributed to the another molecule, then which is leads to formation of coordination covalent bond. What is that? Coordination covalent bond. See, coordination covalent bond is indicated with the arrow mark. Coordination covalent bond is indicated with the arrow mark. See, I am writing like this: nitrogen having 3 hydrogen lone pair of electrons transfer towards the BF3. Yeah. So this bond is coordination covalent bond is formed. Okay. So to formation of coordination covalent bond, one molecule having the excess of electrons, one molecule having the deficiency electron or vacant orbital should be present. Okay. So the two type of molecules are formation of the coordination covalent bond. And next you see here some more examples we are going to discuss about the coordination covalent bond. I am taking one more example. See, water molecule H2O plus H plus, then formation of H3O plus. See, in this molecule also coordination covalent bond is present. Why? Because you see, water molecule having lone pair of electron, H plus, no electron, vacant orbital. This lone pair of electron donated to the hydrogen, then formation of H3O plus it will be formed. H3O plus it will be formed. Okay, so in this type of molecule also coordination covalent bond is formed. Sir, what is the special of this coordination covalent bond, sir? See, what is the special of this coordination covalent bond, sir? Some properties we are going to discuss. First property is that coordination covalent bond cannot ionize in water. Cannot ionize in water. Not separate, not break in water. Okay, cannot ionize. Cannot ionize in water. Okay, and the second point is that this coordination covalent bond is exhibiting space isomerism. Space isomerism. Why? Because it is having the rigid structure. Rigid. They are having rigid structure. Okay, and the compounds, coordination covalent compounds, soluble in organic solvent. Soluble in organic solvent, but sparingly soluble in water. Okay, and one more important point, these are having the polar nature. Okay, means this melting point and boiling point and melting points are in between covalent bond, in between covalent bond and ionic bond. In between covalent bond and ionic bond. But what is that? Boiling point and melting points. Okay, so this is some properties of coordination covalent bond. Okay, right. Now, another one topic we are going to discuss now, that is Fazan rules. Fazan rule. Sir, what is the Fasan rule, sir? What it is explains? See, which is explain the molecules are covalent character, ionic character. Generally, how can we decide? We will discuss. Actually, to calculate the ionic character, we follow the dipole momentum. According to dipole momentum, we can calculate the percentage of ionic character. But Fasan rule, which is explains the ionic nature or covalent nature by seeing the molecule, we can explain on the basis of Fasan rule. How, sir? Just I want to explain simple 4 points. Those you remember, then easily you can recognize the given molecule ionic or covalent by the comparing with another one. By comparing with another one, that is covalent or ionic, easily you can identify. Okay, now see, you remember here one point. Now here I am going to take Ki, Kf, lithium iodide, cesium iodide, lithium fluoride, lithium iodide. Okay, here this comparison I am going to take. Then only we can decide. Given molecular, ionic or covalent, easily we can decide. Okay, anyhow, one simple point I am telling. Whatever the example I have taken here, these all are maximum ionic only. But if we compare these two molecules, which is ionic, which is covalent, we can decide. Now see, by these two examples, here potassium, here also potassium, with respect to potassium, okay, we can't say. With here iodine is there, here fluorine is there. Okay, now see, negative atom, small size, negative atom, large size. Negative atom, large size is there, that is forms covalent bond. Negative atom, small size is there, that is the ionic bond. You remember, negative atom, small size, ionic bond. Negative atom, large size, covalent bond. Now see, positive atom, small size, covalent bond, it will be formed. Positive atom, large size is there, that is ionic bond, it will be formed. Positive atom, small size, covalent character. Positive atom, large size, ionic character, it will be formed. Now see here. Here I have taken Ki, here also Ki. With respect to K, we can't say. With respect to iodine and fluorine, negative atom, small size is ionic bond. Okay, next, here iodine, large size negative covalent bond. So this molecule is covalent. Okay, so like that we can say. Now see, here lithium iodide, here lithium fluoride. Now see, both are with respect to lithium. This is forms which one? Covalent or ionic? This is ionic. Why? Because negative atom is small one. This is ionic. This is negative atom is a large one. This is covalent. Now finally say this. Here two negative atom iodine are same. But this here lithium, electropositive atom, small one. Electropositive atom cesium is the large one. Now tell me, which is forms? Cesium, large one, ionic character. Lithium, small one, covalent character. We can say like this. Okay, this is actually Fasan rule. This point you remember. That's I have given just 2 points. Another 2 points. See, another 2 points, charge. Okay, what is the charge, sir? Na plus, Mg plus 2, Al plus 3, F minus, O minus 2, N minus 3. It means that, see, I'm taking example. Here NaClO, MgCl2, AlCl3. 3 compounds I have taken. Sir, which is ionic? Which is covalent? Sir, all are ionic only. Which is more ionic? Which is less ionic? Tell me now. Okay. Now see the positive charge. See, the positive charge increases, ionic nature decreases. Ionic nature decreases. It means that NaCl is the more ionic, then MgCl2, then AlCl3. This is ionic nature order. Ionic nature. Ionic nature. Okay, right. Now, according to this negative groups, fluorine forms more ionic, then oxygen, then nitrogen. This is also ionic nature order. Ionic nature order. It means that simple one point to remember. That is positive element or negative element, whatever is that. Nearer to the noble gas. Nearer, fluorine, atomic number 9. Nearer, next one step to the neon. Next one step to the neon, then that is formation of the ionic bond. Even sodium also see. One step. Sodium atomic number 11. One electron difference to the neon. So that is compulsory formation of ionic bond. That point to remember. Okay? Right. This is the third point. And fourth point is that the comparison. Now see, here I am taking SnClO4, SnCl2, UF4, uranium, F6O, okay, antimony, SbCl3, SbCl5, SbCl3. I have taken these examples. Now see, sir, tinno, both are chlorine only. Then how can we say ionic nature? Then how can we say covalent nature? How? Tell me. Now we can say on the basis of here tinno oxidation state +4, equal to tinno oxidation state +2. Okay. Now here uranium oxidation state +4, uranium oxidation state +6. So antimony oxidation state +3. Here antimony oxidation state +5. I'll tell you a simple technique you remember. By the technique, we can identify which is covalent, which is ionic. Okay. The point is that more positive charge, more oxidation state, covalent. Okay. Less oxidation state, more oxidation state, more covalent. Less oxidation state, less covalent or ionic. See, now see, more oxidation state, covalent, less oxidation state, ionic or less covalent. Now see, in this two, which is covalent? Sir, UF6, sir, it is covalent. Oxidation state +6. Which is less covalent, sir? Ionic. Less covalent, sir. Now, SbCl3, oxidation state 3, sir. This is less covalent. +5, sir. More covalent, less covalent. Okay, we can identify like this. And lost 1 point. Okay, right. And the point is that the last point, the point is that now see, zinc calcium. This is +2, this is +2. My question is that, which is formation of ionic bond? Which is formation of ionic bond? Tell me. Simple. Which is, both are +2 oxidation state. Both are metal set. Which is ionic character? Which is forms ionic character? It means that calcium atomic number 20, zinc atomic number 30. By loss of 2 electron, which is reaches to the atomic number 18 argon, it is going to reach us to the argon. So it is formation of the ionic bond. But by loss of 2 electron, it is getting atomic number 28. But 28 atomic number not nearer to the argon or krypton. So that's why which atom is nearer to the noble gas element atomic number? Those are formation of ionic bond. This is the last point. Okay. So 3 topics I explained today. Okay. You read this. Okay. Thank you. Thank you very much. Bye.